number 7. Our goal here is to use this function, okay? We're going to complete the table, and then we're going to tell the domain and range of the function, okay? And I'll give you a big old hint on domain and range, which makes it very, very simple, okay? So what it says here is, what we're going to do to complete the table is we're going to choose an A, but as you can see, they have chosen our A's. So think of this as your input. So they let us know our input, and this is our output, okay? So just a reminder, this is like our X and our Y. This is also called domain. This guy's called range. Okay? So real quick, just reminding you of those terms. All right. So what we're going to do is take every single one of these inputs and plug it into our A values, do the math, and then put our answer here. Okay? So the first one we're going to do, and I'm going to do the work down here. First one we're going to do is the function W, and I'm not plugging in A, I'm plugging in 0. So I'm going to put 0. So function W plugging in 0 equals, instead of A, it's 0 to the third minus 0 to the second. Okay? Notice when I plug in, I always use parentheses. Just get in the habit of that. And now we're just going to evaluate, or in other words, we're going to use order of operations to figure this out. 0 to the third power is 0. 0 to the second power is 0. 0 minus 0 is 0. So my first output is 0. Okay, and it's pretty much that simple. We'll come back to these. I'm just erasing this to give us a little bit of room. They'll reappear in a little bit. All right. So now we did that guy. Let's go ahead and do our next input, which is going to be 1. So we got W of 1. So instead of 0 now, I'm going to plug in 1 for A. So 1 to the third minus 1 to the second. So let's do this math. 1 to the third is 1. 1 to the second is 1. 1 minus 1 is, again, we get 0. Okay, let's go ahead and let's do input 2. Okay, so input 2. So I'm plugging in 2. And let's evaluate this. 2 to the third power. Okay, we might start needing our calculator now. 2 to the third power is 8. 2 times 2 times 2. Don't make the mistake of thinking this is 6. Okay, it's 2 times 2 times 2. Let me write that down. All right, so that is 8 minus, and then 2 times 2. And that's 4. 8 minus 4 is 4. All right. Hopefully you're getting the hang of this thing. Okay, let's go ahead and do the next input. So the next one we have is 3. So let's evaluate this. 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. Again, if you're struggling with that, throw it in your calculator. There should be a button in your calculator that looks like this. okay, or y to the x. That's the one you want to use. Okay, let's go ahead, and 3 to the second is 3 times 3. That's going to give me minus 9. All right, so now we just go ahead and do that math. 27 minus 9, and we get 18. All right, let's jump into the last one, 4. So let's plug in 4. Okay, so now we have 4 times 4 times 4 minus 4 times 4. All right, so 4 times 4 times 4 is going to give me 64. And then 4 times 4 is 16. And we get a nice 48 if we do this correctly. So to the 4th power, okay. All right, and that's how you're going to fill the table, okay? Common mistake that we do here is students just struggle with the math here, or they do order of operations incorrectly, okay? Remember, 4 to the 3rd power is not 4 times 3, it's 4 times 4 times 4. I'll get a lot of students that say this is 12, and I'll get a lot of students that say this is 8, okay? All right, so let's go ahead and do part B. Let's bring back our problems. Okay, part B says this. Tell me the domain and range of the function, and here's the hint. Based off the equation, not the table. So what they're trying to say here is, this is not the only domain. Because if you think about it, we could continue plugging in numbers. All right? And we could continue getting outputs. So they don't want you just to use these numbers on the table. They want you to look at this equation and say, what is the domain? Okay, remember, domain is your inputs. And then what is your range, your outputs? So here's the biggest thing you have to understand. Unless it's a very unique equation, most equations that we have up here, especially this one, our inputs will always, okay, 95% of the time, will always be all real numbers. So our domain will 95% of the time be all real numbers. There's going to be unique situations where when we come upon those, I will show you why they are not all real numbers. What this means is, I want you to think of it this way. We can plug in any number for A. Okay? Any number we have could go in. There is no restriction. We can plug in negative numbers if we want. Nothing's going to happen. We can plug in fractions. We can plug in decimals. Okay? So we can pretty much plug in any number for A, and we will get an answer. Because we can plug in any number for A, that means our output, we can possibly get any number. For example, if you look, we skipped like 1, 2, and 3 in our output, right? But if we really wanted to, we could figure out what numbers to plug in so that it equals 1 here. So in other words, our output or our range is also all real numbers. And it's kind of easy to see on the table, because if you look, we're getting all types of numbers as our output. which tells us we pretty much can get any output, okay? We could get any number in our output. So our domain is all real numbers and our range is all real numbers. What I want you to start getting used to is displaying this in two formats, okay? So instead of just writing all real numbers, there's two ways to display it. Okay, the first one is with parentheses. Okay, this is going to give us this. All real numbers looks like this. Get used to this. What this means is I can plug in anything from negative infinity all the way up to positive infinity. If you think about that, that's basically all the numbers in the world I can plug in for A. Okay, so that's one way to say it. Another way to say it is very similar to this. Okay, we talked about this last week. I could say it like this. I can plug in all my A values, so my variable's A. So instead of putting X here, I'm going to put the variable A. And the way we read this is all my A values have to be greater than negative infinity. Okay? So I cannot go below negative infinity, which makes sense because negative infinity is the lowest number possible. So all my A values have to be bigger than negative infinity. So anything I plug in here has to be bigger than negative infinity, but it also has to be smaller than positive infinity. So what we're essentially saying is A is between negative and positive infinity. Kind of like this. We're in between negative and positive infinity. These two guys mean the same thing. So I want you to start displaying your domain in one of these two situations, okay? On your quiz tomorrow, you're going to have a multiple choice problem where you got to choose the correct domain and range. All right, same goes for range. We display it the same way because it's all real numbers. We would display it exactly the same way. So there's two different ways to display domain and range when it's all real numbers. Sorry. Okay, so it looks like this. But instead of putting A here, we're actually going to put our output representation, which is WA. Okay, because we're talking about the outputs in the range. Okay, again, this takes some getting used to. I don't expect you to be like, oh, I got it, I'm good. All right, it takes some practice. So 95% of the time, most of your inputs and outputs will be all real numbers. Okay, when we come upon one that is not all real numbers, I will let you know. Okay, I will let you know what that looks like. Okay, all right, so let's go ahead and do example C. So C says, suppose WA is equal to 18. So we're going to look at the equation. So our equation is this: WA is equal to A to the third minus A to the second. Okay, let me erase these so I can get a little bit more room. All right. So what this question is saying, it says, instead of knowing what A is, we actually know what WA is. So in other words, instead of WA, we have 18. So WA, according to this problem, is now 18. Okay, our goal is to find A. So this problem involves solving equations, which we've done before, okay? But this one's a little more complex of an equation. All right, so what I want to get from you right now is we're not going to solve this out, okay? I don't expect you to know how to solve this out, but I want you to understand this idea that you can also not only plug in for A, but you can plug in for the actual WA, or the function, like we did here, and then have to solve for A. Okay? So if you think about it, we could solve this, or we could look at the table. When is WA equal to 18? So if you look, when is WA equal to 18? WA is equal to 18 when A is equal to 3. So the table kind of solves this for us. A has to equal to 3. Okay? So again, if we didn't have this table, this would be a very complex problem to solve, but the table helped us because all we had to look for is, all right, we're looking for when WA is 18. What does A have to be? 3. If I said WA is 48, then you would say A has to be 4, and so on. Okay? So let's try D. We have W4. So that means W4. So we could plug it in and solve it out, or we could look at the table. Where is W? And we plugged in, instead of A, we plugged in 4. So W4 is really this guy. If you think about it, it's really W, and we plugged in 4 for A. So that means W4 is equal to 48. Okay? So think of it this way. This was my input. If my 4 is my input, what's my output? Okay? Over here it says my output is 18. I need you to find my input. In this case, it's 3. And that's what we have here. We have inputs and outputs. And that's what I want you to think about these problems. So this was my input. This gave me my output. It's all about, when we deal with functions, it's all about input, output, domain, range. Input, output, domain, range. Okay? So when my input was 4, looking at the function W, when my input was 4, what was my output? It was 48. And vice versa. When my output, because this whole entire thing is your output, so when my output was 18, what was my input? It had to be 3. Okay, we got that from the table. All right, guys. I'm going to go ahead and do a problem or two at the bottom. Okay? So this stuff I just wrote is going to get erased. But there'll be a video of it if you need to rewatch it, okay? I'll post that on Canvas. All right. So we have these functions here. We got multiple functions. We got the A function, B function, and C function. So what we're going to do is we want to find, we'll start at 13. We want to add two functions together after we put an input in them. So if you look, we're going to use the C function and we're going to input 4. So let's go to the C function and input the number 4. So the C function says this. It is radical 4, or square root of 4. This actually gives me 2. Okay? Because remember, square root is what times itself gives me 4. The only number times itself that gives me 4 is 2. I'm using this function right here. Okay? Now we're going to plug in 3 into the A function. Let's see what we get. So we're going to add, but let's figure this out first. So we got 5 instead of x. We're going to have 3 squared minus 2. 3 to the second is 9. Order of operations. Okay, and then 9 times 5 is 45, minus 2, and this is going to give me 43. Okay, so my a function turned into 43, and now we're going to add 2 to it from our previous function. What's 2 plus 43? It equals 45. So my answer to this plus this is 45. Okay. All right. That's pretty much what we're doing here. Let's do 15 and then 16, and we'll call it a day. Okay. So give me about 5 more minutes. So 15, our goal is to find the input because we know the output is 43 for A. So we're going to look at A. So AX equals 5x squared minus 2. Okay. So our output, AX equals 43. So this entire thing, AX, our output, equals 43. So we have 43 equals 5x squared minus 2. So our job here is to solve for x. Okay, so we have to kind of remember what we did a couple weeks ago. We want to get x by itself, so we're going to add 2 to both sides. So remember the line, we're going to add 2. Okay, and we get 45 equals 5x squared. Okay, I'll continue this over here. So we have 45 equals 5x squared. And then we want to get rid of the 5. And we remember the 5 is multiplying. So the opposite of multiplication is division. This gives us 9 equal to x squared. Okay. And now here's something that you should, we're eventually going to learn, but I'm going to show you here. Anytime you have to get rid of the power, you do the square root. Power of 2, what you do to one side, do to the other. The little power of 2 and the square root cancel out. The square root of 9 is what times what gives me 9? And that is 3 equal to x. So my input is 3. Okay? All right. So number 16, we're going to talk about is domain. So 16, we're looking at this function. So it's asking what numbers can I actually plug into this function and get an answer. Okay. So you may or may not know this, but this is one of those where the domain's a little different. Okay. Because here's the thing. Square roots, the number inside a square root cannot be negative. So we can plug in any positive number we want. We can never do this. We can never do the square root of -1. If you throw that in the calculator, it will say error. So that means the numbers we can plug in are restricted. So in essence, we got to just plug in positive numbers. Okay? So we want to plug in 0 and positive numbers. So the way we would write that is this. We want to plug in 0. Okay, so we do not want to go below 0 because what's below 0? Negative numbers. So we stop at 0 and we go all the way up to all the positive numbers, which is positive infinity. Okay, and to take this a step further, it's not parentheses at 0, it's a bracket because the bracket says 0 can be plugged in too. So we can actually plug in 0 here. That's what a bracket means. We can plug in 0 and all numbers up to positive infinity. How do I write that in the other format? It looks like this. 0 Okay. To positive infinity. Very similar to what we just wrote here. Okay, so this is your domain. You could write it in this format or this format. Get used to both of them. All right, guys, we'll stop there. That's enough of me talking about this stuff.